Welcome back. My name's Tom Brennan and this is the third video in a series on how to make maps for bushwalking and canyoning using QGIS. If you haven't watched the first two videos, then you should definitely do that, as this one picks up from where we left off. In those videos we saw how to get LiDAR-based DEM data from Elvis, the Australian elevation data site, to load that data into QGIS and merge it, to create contours and style them, to create a slope map and style it, and to create streams and watercourses and style them. We'll be starting from where we left off, so if you haven't still got QGIS open with the data, I'd suggest running through the steps in the previous videos quickly. I've moved my layers panel up to the top of the screen, as otherwise some of the context menus drop off the bottom of the video. You don't need to do this if you don't want to. So we currently have 6 layers, though we're only really interested in 3 of them: the contours, the streams and slope layers. You'll notice a small icon next to each one that looks like a squashed insect. This icon indicates that the layer is temporary. If you hover over it, it displays a message confirming it's a temporary layer. A temporary layer means that even if you save the project, the layer will disappear when you exit QGIS. This can be a bit confusing because you need to save the individual layers separately before saving the project itself. There are 2 types of layers: vector layers like the channel network and contours, and raster layers like the slope. Saving vector layers is straightforward. You can right click on the layer and select Make Permanent. For example, if I do this for the contours layer, I can save it with the file name. Let's call it contours.geopackage. Hit OK. You can do the same for the stream network. Right click, make permanent. Streams.geopackage. However, for some reason, QGIS doesn't offer the Make Permanent option for raster layers like our slope layer, which is annoying. Hopefully it will be fixed in a later version. So what we are first going to do is to rename the original slope layer at F2 as Slope 1. Now we right click on the Slope 1 layer, go to Export and Save As. The default format for raster layers is something called GeoTIFF, which is generally a good choice for standalone raster layers. For vector layers, the default GeoPackage format is recommended, especially for use within QGIS. A lot of external vector data still comes in a file format called shapefile, but GeoPackage is generally a better and more modern format. External raster data most commonly comes in GeoTIFF format, but there are a wide variety of other possible formats. So let's save this as slope.tiff. And then we're going to leave this checkbox here ticked called Add Saved File to Map. So after saving the slope layer as slope.tiff, you'll see a new layer appears on top of the old one, in this case with the name slope. The next step is to copy the styles from the original slope layer to the new one. So right click on the slope 1 layer, select styles, copy style, and then right click on the new slope layer, styles, paste style. And finally you can delete the old temporary layer. Yeah, it's unfortunate that QGIS doesn't offer the Make Permanent option for raster layers, as this would simplify the process by avoiding the need to create a new layer, copy the styles, and then delete the old one. We'll remove the remaining temporary layers as we no longer need them. So you can select the D8 flow, breach and merge layers. Right click and remove layer. So now that you've saved your streams, contours and slope layers, you can save your project. So go to Project, Save As, and I'm going to call it colo.qgz. Alright, so you'll now be able to open up that project any other time after you shut down QGIS. Now, because the slope layer is just a style file on top of a possibly very large raster, it can take up a lot of space when it comes to saving the files. If we take a look here, it's around about 15 megabytes. Converting the slope layer to a much simpler raster can save large amounts of space and make using the data in a mobile device much more responsive. So what we're going to do from the processing toolbox, we're going to use the GDAL raster calculator. There is also a native raster calculator. This one here. So we've got the slope layer as input A, and for the calculation, we're going to paste in this formula here, which looks complicated. I've put the formula down there in the chat, in the description. We'll set the output type to byte, because it's more efficient than the default one of float 32, and we'll hit run. Alright, so let's call this slope 2. We'll go export, save as. Call it slope2.tiff. Add save file to map. Right, so we can now right click and remove the temporary layer. Now we need a slightly different style file to style this layer, but it should look identical in use. So if we double click on this layer, under symbology, style, load style, this is the data from the original mapping workshop again. We want the slope cliffline category.qml. Load style, okay. We'll drag that down to the bottom. So if I turn off that slope layer, you'll see that there's no change to the actual map. And let's go and have a look in our file system at what the size of this file is. So you can see that the slope.tiff is just over 15 megs, and in our case slope2.tiff is under 4 megs. So in this case, less than 25% of the size of the original. And in fact, the original data is actually around about 30 megs. This is already a slightly compressed version. So at this point, I'm just going to remove my largest slope layer, and I can save the project again. The disadvantage of this approach is that you lose all of the raw information relating to the slope map. So if you later decide that you want to use a different set of ranges for the slopes, you'd need to recalculate the slope from scratch. Now, I've been happy enough with my current process, so I've never actually found this to be an issue. Now, we've saved these 3 layers as separate files. It is in fact possible to save all the layers, including the slope layer, in one GeoPackage file. Yes, raster layers can be stored in GeoPackage format too. I'm not going to go too much into the detail of this, but you need to keep saving your layers in the same GeoPackage file, but giving each one a unique name in the layer field. So for example, here you can use the same file, but you just need to use a different layer name. So you can save the streams as streams, contours as contours, and slope as slope. That way you can have one GeoPackage file called colo.gpkg with 3 layers, streams, contours, and slope, and then your project file. To be extra confusing, it is possible to save projects directly into the GeoPackage file. I'm not going to go into this at all because I don't tend to do it myself. It makes opening projects hard, but on the plus side it does mean that you're only ever managing one file. The last thing that we're going to do is to add some grid lines. For this, go to View, Decorations, and Grid. Enable the grid and set the X and Y values to 1000. The units are in meters. Hit OK, and you'll see the lines appear. Notice that the lines exactly align to the boundaries of our map. This is because the data is supplied on the same grid. One thing to note with the grid is that your project should be in a projected coordinate system. This is one where the Earth has been flattened in order to represent it on screen or on paper. You can find the coordinate system of the project in the bottom right-hand corner. The code of our one is called EPSG 28356. Now, if you start with New South Wales Spatial Service DEM files, they are in a projected coordinate system, MGA 94, which is a variant of UTM, or Universal Transverse Mercator. Most projected coordinate systems have meters as their units. If you're in a geographic coordinate system, the units will be in degrees, and therefore 1000 degrees is bigger than the entire Earth. So you probably won't see your grid at all. Something you just need to watch out for if you're bringing in data from other sources. If you're working in Australia, just choose the appropriate GDA 94/MGA zone for your part of Australia, or alternatively use the appropriate UTM zone for that part of Australia. Alright, that's it for this 3rd session. Thanks for watching, and see you next time.